Okay. I read the problem. It says it gives me f prime. That's nothing special. I keep reading. Now it gives me a value of f. And it asks for a value of f. Okay, that is special. That's the most important box on the entire golden node. Look at sheet 1. Go to the right-hand side. Go about halfway down. The most important box on the entire page. Nothing is tested more heavily than that box. Nothing. So it says, if you're given a rate and you're supposed to find an amount, use the fundamental theorem. So that's what I got. They're giving me a rate. They're asking for an amount. Here's my rate. This is the amount they want. I use the fundamental theorem. Fundamental theorem says if I integrate the rate, I will find the difference in the two values of the amount. I'll find how much the amount changes. So my two x coordinates are apparently E and Rudy. That sounds like Rudy, like the movie. Or like Rudy Gobert. Questions? Awesome. Think with me. Hands up. What goes on the other side of the equal sign? Hands. Come on. Hands. More hands. Fundamental theorem. Nothing gets tested more than this. If you don't understand this, you can't pass the test. You're done. I'll state one more time. If you don't understand this, you won't pass the test. I've never had a single student who was good at guessing. I've seen nearly 3,000 of them take the test. None of them were as good at guessing. The ones who couldn't do it didn't pass the test. It was easy. So. Please, Matt. How many knew it? Point, 2 for Matt. Question? Please.
How come these are your limits? Why don't you start at 0?
Oh, 2 points for that. Keep talking to me. The points are going to flow here. Everybody in the room, raise your hand and tell me. When you integrate a rate, what are you always finding? Always. Come on, hands. Everybody. When you integrate a rate, this is the most important part of the entire test. What are you always finding? Allison? Well, that's the method. No, stay with me. That's the method we're going to use. Like, we're going to find the antiderivative of this and evaluate. But in terms of words, 2 points, when you integrate a rate, you get some value. What does that value always represent? Hands up. Come on. Every time you integrate a rate, you get a value. What does the value represent? Go Logan.
Isn't it the distance between the 2 points on the amount?
Lots of different ways to say it. That's a pretty good way. I'm going to say a couple other ways to hopefully make it really sink in. This integral will give me some number. That number is going to tell me how different the two f values are. How different the two f values are. So we know that at this x coordinate, here's the value of f. Let's draw a graph. If you drew a graph of f, here's what you would know. Okay, E is about 2.7. So root E is about 1 point something or other. So here's root E. Gobert. So there's root E. And the value of f there is 5. Questions? Okay, this integral is going to tell me how much does f change? Like, how different is the new y value when we get over here to actually e? So that's why I've got to go between these two. Because I have to go between where I know the value of f to where I want to find the value of f. Because the integral tells me how much the change is between the two values.
So is the reason that I'm thinking we should start from 0 because in most problems they give you the initial condition, whereas this one they don't give you that, so you have to use 3.
Listen close. Listen. Your thinking is perfect. Many problems, they'll give you the value of f at x equals 0. That's why we start at 0. It has nothing to do with 0. It's simply that's what they give us. And really the word initial condition doesn't mean 0. It just means what they gave you initially. With me? 2 more. There you go. Awesome. So now we do what Allison said. Come back over here. We say, well, what we really say is, I wish this was the calculator section, because now I would just pick up my calculator and be done in about 20 seconds, but whatever. So I got to do by hand. So this is where I'm like going, okay, glad I graduated from college and I don't have to do it by hand unless it makes sense to do it by hand. So I can just use my computer. F prime is 2 over x. That's the same thing as 2 multiplied by 1 over x. So now instead of doing the integral on our calculator, we have to find the antiderivative and evaluate. So the antiderivative is going to be 2 multiplied by natural log, absolute value of x, and that gets evaluated between root e and e. Questions? Please.
If you don't think to do 2 times 1 over x, like, will that mess you up in the problem after?
Not really. If this doesn't help, Emmy, keep talking. All I've got to make sure I do is when I look at this, I say, okay, what rule am I going to use? Well, I don't have an antiderivative rule for 2 over x, but the 2 really is just a multiplying constant. That's why you can say I could pull the 2 out to here. So like you could put the 2 here, and then you have 1 over x. Either way. 2 points. Allison?
You only like change the limits if you use the substitution.
Correct. The only time we change the limits in our class, there might be other situations, but for our class, we only change the limits if we're doing a u substitution, where we're changing everything from x to u. Logan?
If you take the natural log of e within
Yep.
so we can solve those ones.
Yep. So what Logan just said is, when I go to evaluate this, I'm going to have 2 times the natural log of e, absolute value. But the absolute value of e is just e, minus 2 times the natural log of root e. But root e is the same thing as e to the 1/2. That's all equal to f of e subtract 5. And you always got to keep track of your equal sign. Points for Logan, please.
Wait, why is it equal to f e minus 5?
So right in the very beginning, are you good with this one, Autumn?
Yeah.
So this is equal to 5.
Oh, okay.
You see it? 2 points. Please, Matt.
I had a question for the earlier equation. When you do the antiderivative of multiplying constant, would it be 2 multiplied by x?
Sit louder, Milo.
Like, wouldn't it, because the...
Matt, sorry.
You're finding an antiderivative, so when the multiplying constant, the antiderivative of just 2 would make 2x.
Oh, same thing. If this doesn't answer your question, ask again. What you're thinking is if I had the antiderivative of 2 alone, that antiderivative is for sure 2x. That's not what we have. We have the antiderivative of 2 over x, which means we got to move that multiplying constant away, like so. So now we're only finding the antiderivative of the 1 over x. Does that answer your question?
If it was 2 plus 1 over x, then would his thinking be correct?
Yeah, it's back to this again. Always keep track of whether you have terms or factors. If I have 2 terms, 2 plus a 1 over x, I've got to find those antiderivatives separately. So it would be 2x plus the natural log of x. Good point. Try and finish here. the question? Please.
This isn't pertinent to the question, but on the FRQ part, if you use the arrows like that, will that dock points at some point, or?
As long as you're using the equal sign appropriately, like you're truly showing what's equal to what, my arrow is just showing the greater that I ran out of room, I couldn't keep going down. So he'll be fine with that. 2 points. So, as was stated, that's going to be simply 2 minus, okay, got to memorize, natural log of e to any power is just the power. So that becomes 2 multiplied by 1/2, which is 1. Okay, raise your hand, please. What does that represent? Come on, that's the value of the integral. Most important concept in the entire class. That's the value of the integral. What does that value represent, Jake?
The difference between the square root of e and e.
The difference between the value of f here, a little hard to say, but you did fine, and the value of f here. So because the value of f here was 5, the value of f here is now 6. That's what it's telling you. How many knew it? 2 for Jake. Please.
So if we were asked to like say what this integral stated, like on a,
Say it one more time, look.
like on a AP question, if we were asked to say like what the integral meant in terms of like the units, can we just say the displacement between these 2 points?
It is. I can't remember if the word displacement is kind of reserved for position and velocity, but it is the same idea. And it's actually a really nice word because it's so hard to get that phrase out of like, okay, it's how different the value of f is at e versus blah, blah, blah. It really is the displacement, it's the change. So 2 points. Cool. Stop the video.